And good morning, afternoon, evening, everyone, from wherever you are located. And welcome to iTrust webinar on Cyber Risk Management Study in Shipboard Operational Technology, or OT Systems. My name is Mark Goh, and I'll be your MC for this webinar. And this will be the first of 3 webinars that iTrust will organize around this topic. And for those who are unfamiliar with iTrust, we are a Center for Research in Cybersecurity at the Singapore University of Technology and Design, SUTD. And before we begin, iTrust wishes to thank the Maritime and Port Authority of Singapore, MPA, and the Singapore Maritime Institute, SMI, for their support in this webinar. We also like to thank SMI for funding iTrust to carry out this 1-year research study. And here is the program for this morning's webinar. Dr. Sanjay Kutan, Executive Director of SMI, will kick off this webinar by giving his welcome remarks. Professor Zhou Jianying, the study's principal investigator, will provide an overview of the research study. Priyanga and Ruchita, our senior research assistants, will share a list of shipboard operational technology systems that are under consideration in this study, along with their corresponding cyber risks. We will then open the floor to take questions and feedback from you. And Prof. Zhou will then close the session by summarizing the presentation and the discussion. And without further ado, it is now my pleasure to invite Dr. Sanjay Kutan to give his welcome remarks. Dr. Kutan, please.
Good morning, Mark, and good morning, everyone. And if you're in Singapore, it's a nice and chilly morning. And on a Friday, it must have been a struggle to get out of bed. But I'm glad to see more than 200 of you logging on for this session. I really like to commend SUTD in organizing this seminar because it comes very timely during the COVID year 19, where the growth of digitalization has been anything but exponential. The maritime sector, whilst it was a laggard in terms of adopting digital technologies, has begun to close the gap with the rest of the pack, and therefore becomes subject to a different type of risk. The maritime sector is constantly exposed to climate change, weather the seas, and now in the digital space, there's a new risk that we need to deal with. And the strange thing about cybersecurity is we're dealing with almost an unknown. Whilst we can patch and protect against attacks that we have been already exposed to, the hackers and the cyber terrorists out there are constantly reinventing themselves and reinventing their approach to get around the various strategies of blocking their entry. So this research is an understanding of the space becomes very important, because we need to be almost literally ahead of the curve, and the curve is a bit of an unknown because the hackers and the cyber terrorists are, I must say, are very talented individuals, and despite their less than noble attitude towards the protection of assets and life. So this study becomes very important because understanding where the vulnerabilities are on shipboard OT systems allows us to begin to understand what and where we need to address. So I'm really looking forward to this session to hear what's going on. And for those of you out there who are ship owners, ship builders, as you constantly make decisions in the boardroom on how to protect your assets and your people, I hope this study will be enlightening. And SMI and MPA, on behalf of MPA, we welcome a greater engagement of the ecosystem to collectively address the threats from cyber terrorists and hackers. so that we can protect both our people and our assets, and more importantly, also the supply chain of goods, which are the lifeblood for a lot of countries around the world, whether it's food and other types of goods. So I'll leave it to the researchers now to enlighten us. And over to you, Mark. Thank you very much, everyone.
Thank you, Dr. Kutan. Prof. Cho, I'll now hand over the time to you to introduce the study as well as the team. Prof. Cho, please.
Hello, everyone. I will first give an overview of this project. As the PI of this project, I'd like to thank the support from MPA and SMI on the research. Our team members include Mark, the subject matter expert, and two researchers, Priyanka and Rochetta. In iTrust, our main research focus is on cyber-physical system security, especially in the domains of water, power, and transportation. This is our new initiative to explore the maritime industry. So we know that maritime industry is one of the key engines of Singapore's economy. It has showed an increased trend of adoption of more ICT technologies in maritime industry, with enhanced monitoring, communication, and connection capabilities. This will significantly improve the productivity and reduce the operational costs. On the other hand, increased connectivity will also introduce more cyber risks. For example, the shipboard OT systems may subject to more cyber attacks. This may disrupt safe operations of a vessel and may cause catastrophic consequences. So we need to establish a guideline for cyber risk management on shipboard OT systems, so that ship owners can use this guideline as a recommended best practice for adoption. Meanwhile, for maritime authorities, they can use it to perform vessel inspections. So far, there are quite a number of regulations and industry guidelines on maritime cyber risk mitigation strategies being proposed from various sources. For example, like IACS recommendations on cyber safety, BIMCO's guideline on cyber security on board ships, NISA's guidelines on good practice for maritime security, and also IMO's guideline on maritime cyber risk management. However, Singapore lacks our own guideline that can be easily referred to and be adopted by maritime authority as well as ship owners. This project started from September this year, and it aims for a cyber risk management study focusing on shipboard OT systems. And we will investigate the existing guidelines for cyber risk management and produce a new guideline for Singapore's context. A couple of factors will be considered in our new guideline. For example, we will consider the balance of risk versus costs, and we will take a tiered security approach for our major shipboard OT systems, and we will make our guideline easy for adoption by ship owners, and also easy for enhancement by our maritime authorities. So today's webinar will share our study of cyber risks in shipboard OT systems. Our study will cover 4 major shipboard OT systems. That is communication systems, navigation systems, the propulsion, machinery, and the power control systems, as well as cargo management systems. Note, here we don't intend to discover new vulnerabilities in those systems. Instead, we will study the cyber risks in those systems first, and then we will consider how to manage those risks as a next step when we define the guidelines. Now I hand over to Priyanka, who will share the study of cyber risks in communication, propulsion, machinery, and power control systems, followed by Rachita, who will share the study in navigation and cargo management systems. Thank you.
Thanks for the brief introduction of our project, Prof. A very good morning, everyone. And now let me start with the slides. First, let us look into communication systems. With ship traffic increasing around the world, it has become ever more important to improve the safety and security of the ship. Advanced communication systems enable ship-to-land, land-to-land, ship-to-ship contact using satellite and land-based radio telephone infrastructures. The state-of-art voice and data communications technology available today means that ship owners and operators and the crew can stay in touch wherever they are. Internet connectivity, being the part and parcel of channels of communication today, allows access to email, weather and chart updates, position reporting, remote diagnostics, and so on. Seafarers also need to be able to communicate with other ships to receive and send urgent maritime safety information and to send or receive distress alerts in case of an emergency. So when critical decisions have to be made quickly to protect or enhance any of these factors, good communication between everyone involved in the maritime chain is essential. So under communication systems, we'll be looking at satellite communication system, integrated communication system, voice over internet protocol, and wireless LAN. The first one is satellite communication system. In telecommunications, it is the use of artificial satellites to provide communication links between various points on Earth. Vessels require broadband satellite communication solutions that deliver 24/7 ship-to-shore connectivity and to stay connected to their main offices and to support crew welfare activities. Basically, navies will have higher bandwidth requirements to support mission-critical applications such as real-time operational command and control, remote equipment monitoring, and live surveillance. In all of these scenarios, maritime VSAT solutions must be able to ensure global coverage and maximum system availability even under the harshest weather and operational conditions. Note that satellite communications can be the entry point for various malicious cyber threats. As ships are becoming further automated and onboard systems are more connected to the internet, owners, operators, and managers must ensure that they have adequate protection and the ability to recover rapidly from a cyber attack. We look at some of the cyber risks. Usage of VSAT hardware, which is a very small aperture terminal satellite communication hardware, it can be vulnerable if the software is not updated and the passwords are not regularly changed. BIMCO recommends operators to change administration passwords away from the default ones, as hackers can easily find them on dark web, and because of this they can even access the terminal administration interface. Ethical hackers also discovered that some modems only support insecure protocols such as hypertext transfer protocol and telnet, and they use it for their management, and they are vulnerable to reflected cross-site scripting on the web interface. So this meant hackers could add their own code to the modem, execute them, or create fake passwords and also capture cookies information. And also phishing emails from unknown sources attempt to deliver Trojan malware, and that could include ransomware and cryptocurrency miners. Now we'll look at an attack scenario. So the first one is a cross-site scripting attack, where the hacker will send or inject a malicious payload into a vulnerable web interface, and when the victim or the crew, when he visits the website, then he will actually trigger the malicious script, and because of this the browser will execute the payload and forward cookie information and other information to the attacker. Another scenario is where he can log into the web interface with default credentials. As I said earlier, he may access it from dark web. And if the login is successful, then the entire SATCOM system is compromised. And because of this, communication is impossible even during the time of distress, which is not good for the safety of ship. The next one is integrated communication system. Basically, Shipboard Integrated Communication System is an IP-based integrated communication system designed to suit the mission-critical needs of today's navies. Designed for lead manning, the system optimizes interconnectivity, survivability, and interoperability. It enhances situational awareness through centralized management of disparate communication systems and devices, resulting in an enhanced operation efficiency and incident response. So some of the key features of integrated communication systems include satellite and radio communications, intercom, WAN, and LAN. As these systems are more interconnected, the cyber risk associated with them will also have huge impacts. Looking at the cyber risk, so an attacker can easily access the terminal administration interface if all they need to use is a default password that will allow them to take control of the satellite terminal. So once hackers are into this interface, they can access critical networks on the ship, tamper with the software, or even introduce security flaws. Also, they can gain access to the administration area, which is the entire operating system of the device, and all the usernames and passwords can be changed by them. And because of this, access to FTP is also possible. And if this has not been enabled before, they can actually enable it as they are in the admin area. Also, if command line access to the modem is achieved, it can allow the hackers to take control and alter the configuration of the system. Let us look at an attack scenario. So the attacker hacks the VSAT modem through either default credentials or through the web interface, and he has command line access, for example, telnet access, and he has access to modem and tamper the configurations in such a way that the system will be compromised and communication is impossible. Also note that because of the command line access, the hacker might change access controls and directory structures, which makes it hard for the crew to operate further. The next one is Voice over Internet Protocol. VoIP is a proven technology that lets anyone place phone calls over an internet connection, as we all know. The ship's crew can make or receive calls from different parts of the ship with the help of VoIP. Ship owners, especially those who operate multiple numbers of ships scattered in different locations, can communicate with their sailing vessels and provide immediate and clear instructions to ensure the crew and passenger safety. Let us look at some of the cyber risk. The first one is denial of service attack. So when a denial of service attack occurs, A hacker floods the VoIP network server with SIP call signaling messages, which is the session initiation protocol messages, which will consume the available bandwidth and slow down or even stop the system traffic. This halts the incoming and outgoing VoIP calls and can disrupt the flow of communication. So if the crew is not able to make calls through VoIP even during an emergency, then it is a big threat to the safety of ship. The next one is eavesdropping, which is one of the most common VoIP threats. Audio streams are intercepted with no authorization, putting information from conversations at risk. Unfortunately, packet capture tools allow hackers to tap into any unencrypted VoIP traffic, making conversations easily accessible. It is essential that the VoIP traffic is encrypted, as crew members may converse confidential information. Another threat is phishing, which is VoIP-based phishing or voice-based phishing. Attackers pretend to be reputable businesses such as banking institutions or credit card companies and trigger the victim to give out confidential information. So here necessary training must be given to the crew on how to respond to such calls. Another issue to be considered here is that malwares and viruses do a lot of damage and they contribute to future vulnerabilities by creating Trojan backdoors. So these backdoors leave gaps in the system security so that the future hackers can exploit them and tamper or even steal information that is relayed in the calls. Let us look at an attack scenario where the hacker floods the VoIP network with a lot of packets from different sources, which is, I said, the SIP call signaling messages. And because of this, the network is congested, as a result of which the service is disrupted. And due to this, communication is not possible even during distress. Another scenario is eavesdropping, where a victim is using a VoIP phone in an unsecured connection, and the hacker is eavesdropping on this unsecured or unencrypted network, and because of this, a lot of confidential information can be disclosed. The next one is wireless local area network, which is a wireless computer network that connects two or more devices using wireless communication to form a local area network within a limited area. In ships, it is used for connecting devices and to the port and office environment so that they can access internet and other resources. Some of the cyber risk is the usage of default SSID and passwords, which is definitely not safe. Usually, Wi-Fi access points are shipped with a default password and SSID, which needs to be changed, but all too often they are not changed. So this makes it easy for an attacker to log in and take control of the router, change the settings of firmware, or even load malicious scripts. Another thing to note here is that the Wired Equivalent Privacy Protocol, which was the first protocol used to encrypt wireless traffic. WEP was intended to make wireless networks secure, but it has its own vulnerabilities because of poor encryption. So if we want to improve security and prevent LAN attacks, then we must upgrade to Wi-Fi Protected Access 2 or Wi-Fi Protected Access 3, which use the much more secure advanced encryption standards, and they do not have any of the vulnerabilities of WEP. Another risk is malicious eavesdropping, which is very illegal, and this is where someone tries to listen in on the data that is transferred between the client and the access point. And because of this, it is very essential to encrypt our network, as anything that is unencrypted can be easily listened on. We look at a similar attack scenario wherein there's the hacker who floods the access point with a lot of requests. And because of this, the network is congested and the service is disrupted or even slowed down. And if the monitors are connected to LAN, then chart updates cannot be done if there is no access to email. So because as far as we read, the crew members will actually download the charts from email and then insert it via the USB. and because of this, the ship will be idle until the connection is restored. Another scenario is eavesdropping, where a victim uses an unsecured network connection and the attacker eavesdrop on this network without their knowledge, and a lot of confidential information can be disclosed. We look at some of the cyber incidents related to communication systems. In February 2020, Dirat Global and Red Sky Alliance Company published a report identifying new phishing emails attempting to entice shipping company employees to accidentally start Trojan malware, and there was an increase in malicious email attempting to deliver this kind of malware, which might include ransomware and also cryptocurrency miners. Also, there's another scenario in May 2020. Ivan Robinson, the director of YangoSat, a maritime communications and solutions provider, reported that the ethical hackers were able to compromise the communication system of the ship by hacking VSAT terminal. They actually located their target vessel in 7 minutes, and they said it belonged to a very large multinational corporation, yet they had the default username and password still on effect in the VSAT system. So this allowed them to easily gain access to the administration area, and it also gave them access to FTP. So a few major security flaws were found. The FTP access gave them access to the entire operating system of the device, not just the FTP area. Another security flaw was that they discovered a text file in every folder which had the map of entire structure of the operating system. So this basically allowed them to copy the hidden password file to their own local machine. Also, command line access to the modem was achieved, allowing them to take control and alter the configuration of the system. So the next topic is propulsion, machinery, and power control system. Ship's machinery is an important topic in case of security. Plenty of systems are directly interconnected with navigation systems and data analysis servers or softwares, which is mounted in the business part of the network. It might happen that some of these systems might have input ports through which it is possible to perform attacks. Since electronic programs control the physical actions of the ship, they can fall victim to a cyber attack and threaten ship control, especially when they are connected to remote condition-based monitoring and they are integrated with navigation systems. So under propulsion, machinery, and power control systems, we'll be looking at engine governor system, fuel oil system, alarm monitoring and control system, power management system, emergency generators, and batteries. So the first one is engine governor system. The engine system is a vital part of the ship. It is mainly used to maintain the mean speed of an engine under fluctuating load conditions. The figure on your right represents the schematics of engine control. Note that the first controller present to the left on the picture is the knocking controller, which is responsible for controlling fuel and air properties. And the second controller placed in the middle of the figure is the dual fuel controller, which is responsible for general engine control like engine speed, and it also has the abilities to send diagnostic data to other system that is placed on the bridge. Communication with the rest of the ship system is done through the NMEA network, and I will talk a bit about NMEA network here. So just like humans, marine electronics also have languages. The most common one today is NMEA, a digital language sanctioned by an industry association known as National Marine Electronics Association. So for interfacing marine electronics, the NMEA serial network is utilized as the communication standard. So this protocol utilizes the controller area network for transporting digital information between devices, which is a robust bus vehicle standard that is designed to allow microcontrollers to talk to each other without having a host computer. So NMEA is like a multi-line superhighway where entire digital conversations are spread along 2 directions simultaneously. With NMEA, it is possible to have the GPS or the chart plotter to send steering commands to autopilot. However, NMEA messaging is also used to control other systems like ballast pumps, propulsion, steering, and many more. Note that NMEA sentences are plain text and they have no message authentication. It would be trivial to intercept the message data on the network and modify the vessel's course. Looking at the cyber risk, so if the attacker has access to the NMEA network, as I said, it is not secure, then he can manipulate the dual fuel controller to provide wrong control. One scenario is that dual fuel controller must send information about oil pressure to the oil loop system. It is possible to hack these messages so that the oil loop system would provide less oil to the engine, and therefore at some point the engine would be stalled. Another scenario could be that hacker can compromise the knocking controller, which would eventually drop the engine's efficiency. We look at an attack scenario. So there's the attacker who hacks the VSAT, which is the satellite communication system of the ship, through which he breaks into the ship's network and tampers the NMEA messages that is being sent to or from the engine system in such a way that the engine system will fail. And because of this, the ship will be idle as the engine's efficiency has dropped due to malfunctioning. The next one is fuel oil system. The basic requirement for any marine engine is to propel a ship or to generate power on board by using the energy obtained by burning the fuel oil. The fuel oil system usually involves a lot of machinery to maintain it in a secure way. The figure on your right is presented a part of the heavy fuel oil system. So one side of the fuel system is connected to other fuel treatment systems, and on the other side, the oil system is connected to engine controller and to other parts of the ship. Note that the fuel oil system is connected to the NMEA network. So for sure, the NMEA network is not secure. So it is possible to edit any information that is going in and out of the system. Looking at the cyber risk, as I said earlier, the system is connected to NMEA network. A possible attack is, for example, manipulating the fuel level indicator to show a wrong fuel level compared to the real level of fuel. So this can lead to problems like not getting to the destination port by vessel or even overloading the tanks. So we look at an attack scenario. So there's an attacker who hacks the VSAT system, which is the SATCOM system of the ship, through which he breaks into the network and tampers the NMEA messages that is sent to or from the fuel system. As I said, a possible attack might result in tampering the fuel level indicator to show wrong fuel level in the indicator panel, and because of this, the ship will be confused, and even overloading the tank will cause leakage, which is not safe. The next one is alarm monitoring and control system. This system allows controlling all the alarms implemented on the vessel. The alarm system links all the systems in the ship and gives out audio and visual signals in case of an emergency situation. The alarm manager is the core alarm installation that is working on the NMEA network. Looking at the cyber risk, the system is connected to NMEA network and NMEA is not secure, so hackers can send wrong commands to the alarm system, which will result in fake alarm or even alarm failure. This might be done by the hackers in order to distract the crew, and so that by that time they can try to disrupt any other operations or systems. Similarly, a same attack scenario where there's a attacker who hacks the VSAT and gets into the ship's network and tampers the enemy messages that is being sent to or from the alarm system. And because of this, the alarm system will fail to show up an alarm or even give out a fake alarm. And because of this, the ship will be in danger, because if even an emergency situation is not highlighted, then it is not good for the safety of the crew and the passengers. The next one is power management system. So this system's goal is to provide stable electricity to all the vessel's components. In general, it consists of main switchboard, emergency switchboard, and diesel or turbine generators. Control over power management is automated, as you can see in the figure. One case to consider with power management is the air-conditioned containers, and they have to have constant electricity delivery over their period of transportation. The similar story is applied to classical containers and the big tanks, which are used to transport, for example, liquid fuel or gas, which have special valves and sensors to control the concentration of evaporated fuel inside the tank and also controlling the temperature. So all these have to be controlled, because if not, then pressure might rise up and it will end in fuel ignition or explosion. However, hacking this system might result in big money losses because the container's content can be damaged. Looking at the cyber risk, the system is obviously connected to enemy network, and in case the power management system is compromised and if power distribution is not done properly, then it might damage the container's content, as it may require uninterrupted power supply throughout the voyage. For example, the reefer containers. And if any USB port is present in the system, then malware can be injected that would lead to disruption of normal operation. And also unauthorized access to other systems resources can also be done. So we look at a similar attack scenario. As I said, the crew can inject virus via USB into the USB port of the power management system, which will cause the power management system to fail. And because of this, the switchboards cannot be operated properly. Another scenario is where the attacker hacks the VSAT, which is the SATCOM of the ship, through which he breaks into the ship's network and tamper the enemy messages that is sent or received to the power management system. And because of this, the power management system will fail. As I said, the shipboards and the controls cannot be operated properly. And because of this uneven power distribution, the displays can be switched off and even the container's content can be spoiled. The next one is emergency generator and batteries. In case of the failure of the main power generation system of the ship, an emergency power system or a standby system is also present. The role of the emergency generator on the ship is to provide backup power for the emergency loads in case the main generator fails or in case a blackout condition occurs. Emergency power can be supplied by batteries or an emergency generator, or even both the systems can be used. The emergency generator is connected to its own emergency switchboard, which is connected in parallel with the main switchboard. Both the emergency switchboard and the main switchboard are present in the power management system panel, which is present in the ship's bridge. As I said earlier, the power management system is connected to the enemy network, which is highly vulnerable to cyber attacks. Basically, the voltage and the frequency is monitored in the main distribution panel, and in case of failure, the automatic transfer switch will sense the absence of power in the main line, and it will create the transfer switch to automatically drive power from the emergency generator for providing power to the desired systems. Looking at the cyber risk, as I said earlier, cyber attacks that cause the power management system to fail will affect the automatic start of emergency generator. So if an attacker compromises the power management system, then the switchboards cannot be operated or controlled properly. Thus, if the emergency generator is not switched on when the relay senses that the voltage is low or when there is a blackout condition, then actually one can do manual startup at the generator room, but any delay in switching on this automatic emergency generators might cause the content in the cargo containers to spoil. As I said earlier, for example, the refrigerated containers or the reefer containers, they require constant electricity throughout their voyage. We look at an attack scenario. So the attacker gets into the SATCOM of the ship and tamper the NMEA messages. And because of this, the power management system will fail, due to which the emergency generator might not turn on. And obviously the container contents are spoiled, and also ship will not be able to move further because all the displays like GPS, AIS and ECDIS will be turned off. So there will be no information on voyage. And also there might be no communication available. And now we'll look at some of the cyber incidents related to propulsion machinery and power control systems. In the beginning of 2015, McAfee found some vulnerability that actually allowed them to create ransomware. This vulnerability allowed them to take total control over propulsion systems and navigation, and it was possible for them to infect the vessel through an unsecured network connection. The attacker was also able to encrypt essential system components so that no one could control the ship. Another scenario was in 2017, where the Naval Dome Ethical Hacking Group, they chose to penetrate the machinery control system of the ship using a USB stick which was infected with virus. And once they connected the USB to the vessel's MCS, the virus file ran itself, and it started to change the functionality of auxiliary systems. Their first target was the ballast system, and the effects were really startling. The displays were actually presented as perfectly normal, but the valves and the pumps were disrupted and they even stopped working. So the hackers said that they could have also misled other auxiliary systems like air conditioning systems, the generators, engine governors, fuel systems, and many more. So that's it from my side. I'll hand over to Ruchita to continue navigation systems and cargo management. Thank you for the opportunity.
Thank you, Priyanka, for your slides. Good morning, everyone. Now I'm going to present possible cyber risks of navigation systems and cargo management systems. Coming to the navigation systems, with modern day facilities and automation, a ship today has several advanced navigation equipment systems which give accurate data for the voyage. There are many subsystems in navigation systems which are helpful for navigation in their own way. The first one is ECDIS, Electronic Chat Display and Information Systems. Whereas these ECDIS is a development in the navigational chat system with the use of these electronic chat system. It has become easier for a ship's navigating crew to pinpoint location and also to attain the directions. Next one is radar. The radar is one of the most used equipment systems on board ships. It is designed for detecting and tracking targets for a considerable distance. Other subsystem is AIS, Automatic Identification System. This AIS displays other vessels in the vicinity. It is fitted on ships for identification of ships and also to identify navigational marks. Next one is GPS, Global Positioning System. Whereas this GPS displays the ship's location with the help of the satellite in the Earth's orbit. Other subsystem is DPS, Dynamic Positioning System. The dynamic positioning system automatically controls the position and also heading of a vessel by using its own propellers and thrusters. Next one is GMDSS, Global Maritime Distress Safety System. The goal of GMDSS is to virtually guarantee that vessels will be able to communicate with an onshore station at any time from any location in case of there is any distress or to exchange any safety related information. And next one is VDR, Voyage Data Recorder. Whereas Voyage Data Recorder behaves like a black box which continuously saves all necessary information about the ship. The final subsystem of navigation system is INS, Integrated Navigation System. Whereas this INS enhances the effectiveness and safety of the ship navigation by integrating at least two navigational functions. For example, like integrating radar, ECDIS and AIS together. Now I will discuss more in detail about each subsystem. The first one is Electronic Chat Display and Information System, ECDIS. You can see in this picture the screen of the ECDIS where this display displays the navigational points, radar information, and also weather, ice conditions, speed, position, and planned route of the ship. The possible cyber risks included in ECDIS are denial of service attack, spoofing attack, and virus. Here we can see the attack scenario of ECDIS. The crew member, intentionally or unintentionally, can inject virus through USB into the vessel's ECDIS. Now, as ECDIS contains the virus, the attacker can gain unauthorized access by using the network services and also can gain unauthorized access to the internet. Then the attacker can perform the spoofing attack. As we all know, the ECDIS uses the NMEA network in order to communicate with the other systems in the vessel. This NMEA network transfers the messages in plain text. So the attacker will perform the spoofing attack and the attacker can change the messages. Even the attacker can changes the display of ECDIS. Whereas it may lead to cause the collision of the ships. The another possible cyber risk the attacker can perform is when the attacker gains access to the internet, he can also gain access to the local area network. Then by gaining the access to LAN, the attacker can steal electronic navigational chats, and also the attacker can gain access to the other data in the system. The attacker can also overload the network by sending the packets. When the attacker overloads the network, the attacker can perform the denial of service attack. By performing the DOS attack, the ECDIS will be offline. So no more the staff can be used the ECDIS display. This is the attack scenario of ECDIS. Next subsystem is radar, radio detection and ranging. This is the mandatory equipment of navigation. And here you can see in the picture the radar antenna, which is used to receive the signals. And here you can see the screen of the radar, which is used in identifying, tracking, and positioning of vessels, among other things, in order to safely navigate a ship from one point to another. The possible cyber risks in radar are malware intrusion and man-in-the-middle attack. Here is the attack scenario of the radar. When the attacker gains access to the ECDIS, then the attacker can inject the virus through local Ethernet switch into the vessel's radar. Once the virus injected into the vessel's radar, the attacker can change the display of the radar. Then these may lead to blindfolding the ship. Sometimes it may also cause collision of the ships. And these vessels' radar uses the server message block service. This server message block version has some vulnerabilities. That means there is no signature for the messages transmitting through the server message block service. Due to this vulnerability, the attacker can perform the man-in-the-middle attack, and the attacker can gain remote and unauthorized access to the system. Even the attacker can execute the code without any authentication. This is about the radar. The another subsystem is automatic identification system. Here you can see in the picture, this is the AIS system, and here you can see the radar screen, which is displaying the other vessels in the vicinity. So this automatic identification system helps in obtaining the detailed information of any ship. Even it will be the name, speed, position, and direction, rate of turn, destination, and also the physical dimensions such as length, breadth, tonnage, beam, and draft to the nearby ships, and also to the coastal authorities. The possible cyber risks of AIS are spoofing attack, replay attack, and frequency hopping attack. Here you can see the attack scenario of the AIS. Whereas the vessel AIS has the AIS software, this software has no built-in security and also no authentication. So the attacker can perform the closest point approach spoofing attack. That means the attacker can create a fake terrestrial tower, and by creating that fake tower, the attacker can also create the fake vessel. Then these fake vessel will be displayed in the ship's radar screen as the nearest vessel approaching. By this, the CPA alert will be triggered. That means closest point approach alert will be triggered in the vessel, whereas it leads to run vessel aground. And the attacker can also perform the replay attack. That means the attacker can delay the transmission time of sending the information from one ship to the another ship. And the attacker can repeat this over and over. By repeating this over and over, the attacker can make the AIS display disappear. The another vessel's AIS uses the very high frequency radio for communication so that the attacker can perform the frequency hopping attack. Actually, the port authorities will fix a standard frequency for communication. So the attacker, when once gain an access, the attacker can switch that frequency to the blank. So these will disturb the communication. This will disturb the transmitting and receiving of the messages, and it may also lead to the loss of the communication. The next subsystem is global positioning system. Here you can see in the picture the display of the GPS, which shows the ship's location with the help of the global positioning satellite in the Earth's orbit. This location will be used by AIS, automatic identification system, and also by the ECDIS to update its chats in order to safely navigate the ship. The possible cyber risks of GPS are GPS spoofing and GPS jamming. Here we can see the attack scenario of the GPS, whereas the attacker transmits the spoofed signals to the GPS receiver. As this GPS receiver receives the spoofed signal, it will display the false position in the GPS display instead of showing the original location, so that it can make the ship to stay idle at the sea, and also sometimes it may lead to the collision of the ships. The attacker can also perform the interference of the signals, that means jamming of the signals. Due to this jamming, the attacker can prevent the GPS receiver from receiving the signals. As GPS receiver doesn't receive the signals, there will be no position displayed on the automatic identification system display, and also there will be no update on the chats on ECDIS display. Next subsystem is DPS, Dynamic Positioning System. DPS system is a computer control system which automatically shows the vessel's position and also the heading by using its own propellers and thrusters. Some ships will have specific display for the DPS, but some ships will use the ECDIS display for DPS functioning. So here you can see on the ECDIS display, the vessel will automatically maintain a vessel's position and also the heading of the ship. The possible cyber risks of DPS are denial of service attack, spoofing attack, and backdoor attack. Here you can see the attack scenario of the DPS. Whereas the dynamic positioning system has the poor software. Due to this poor software, the attacker can create a network storm to the global navigational satellite system receiver. So the attacker can perform the denial of service attack. By performing this DOS attack, the attacker makes DP controller unavailable. And the attacker can spoof the signal and send the spoofed signal to the GNSS. Due to this, this will show the wrong position on the DPS display. As wrong position is showed on the display, these may cause change in the heading of the ship. Here you can see this should be the original heading of the ship, but due to the wrong position, the ship's heading is changed. And there are some security vulnerabilities in the DP system software. Due to these vulnerabilities, the attacker can gain unauthorized access to the system. When he gained the unauthorized access, the attacker can perform the backdoor attack and can download the data and also can make changes to the system. Next one is Global Maritime Distress Safety System, GMDSS. Here you can see the display of the GMDSS, where it is used to send the distress signal via a satellite or radio communication equipment. It is also used as a medium for sending or receiving maritime safety information, and sometimes it can be used as general communication channel. The possible cyber risks of GMDSS are spoofing attack, eavesdropping attack, denial of service attack. Here we can see the attack scenario of GMDSS, whereas the GMDSS uses the very high frequency for communication. This VHF has no confidentiality. Due to the lack of confidentiality, the attacker can install the malicious firmware into the system. Once the malicious firmware is installed, the attacker can control devices on board. Even the attacker can disturb the communication, and also the attacker can perform the spoofing attack by delivering the false information. For example, he can deliver that there is some distress, even there is no distress or anything, any safety information in this ship. This GMDSS uses the plain text messages for communication. As there is no security for this plain text messages, I mean there is no encryption, the attacker can perform the eavesdropping attack and can manipulate these messages. The attacker can gain access to the internet and can download the malicious documents into the system through internet. I mean, for example, it may be through email also, one type of phishing attack. Then the attacker can perform the denial of service attack, which causes loss of the communication. Next one is VDR, Voyage Data Recorder. This VDR behaves like a black box and records the various data relating to the position, movement, and physical status, even the command and control of the ship over the period. It may be 2 for 12 hours, for example. So, which is used in reconstruction of the voyage details and also some important information during any accident investigation. The possible cyber risks of VDR are remote code execution and malware. Here we can see the attack scenario of the VDR, where the crew member can inject the malware through USB into the vessel's VDR. Once the malware is injected into the VDR, the attacker can gain access to the VDR system. Then the attacker can store the important data stored in VDR and also can destroy that data. Even due to the vulnerabilities in VDR, the attacker can gain root privileges. That means administrator privileges. Once the attacker gains the administrator role, the attacker can execute the code into the system and he can delete the conversations. And also attacker can delete the radar images in the VDR. Next one is integrated navigation system. This integrated navigation system is a software platform which combines the data from major ECDIS and radar systems and also from the AIS for providing additional navigational functions of the route. It will use the protocol server in the backend in order to communicate these systems. The possible cyber risks of INS are man-in-the-middle attack and remote code execution. Attack scenario of the INS is where the INS system uses the protocol server to connect the ECDIS, AIS, and radar. This protocol server has low encryption. Due to this low encryption, the attacker can perform the man-in-the-middle attack and the attacker can gain remote and unauthorized access to the system. Even this integrated navigation system uses the server message block service. This server message block service has the vulnerabilities. That means there is no authentication for this SMB. As there is no authentication, the attacker can gain access to the INS system and he can execute the code into the system. He can execute his own code here. Next one is cargo management systems. Whereas the cargo management is made for easier, faster, and more reliable way of controlling and tracking cargo, where these cargo management system consists of multiple smaller systems which cooperate together and depends on a ship, they can be more or less automized. Like for example, when it comes to the liquid container ships, the cargo management system should be there for sure to control, regularly monitor the level of the liquid and also regularly to track the cargo. And when coming to the solid cargo, simple cargo, the cargo system may be less automized. Under the cargo management systems, we have cargo control room and ballast water system. I will discuss more in detail about these subsystems. Coming to the cargo control room, here you can see the picture of the cargo control room where the person in charge can regularly monitor and control the operation of cargo, even the loading and unloading of the cargo from these cargo control room. The possible cyber risk of cargo control room are ransomware and malware. Here you can see the attack scenario of cargo control room, whereas the phishing email, which contains the virus, can be sent through Shipboard network into the cargo system. Like any of the crew member can click the link of that email. Then the attacker can log the system until some ransom is paid. Even the crew member can inject the can inject the malware through USB into the cargo system. Then, due to the malware present in the system, the attacker can steal the data. Like for example, there will be a data like pins for the specific delivery of the cargo. If the rightful owner come to the port and give the pin, then the cargo will be delivered to that owner. So when the attacker steals that important data, that pins, the wrongful owner can collect the cargo. This is the attack scenario of the cargo control room. And the next one is ballast water system. This ballast water system is a compartment within a ship which holds the water as a ballast to provide stability of the ship, like using water in a tank, which allows for the easier adjustment of the weight. Here you can see the picture which maintains the stability on the starboard side and port side. Possible cyber risks of the ballast water system are phishing, malware, and virus. Coming to the attack scenario of the ballast water system, the attacker when gain access to the bridge system, that means the navigation system. Once the attacker gain access to the ECDIS, radar, any of these systems, then the attacker can make engine system to send false command to the ballast compartment. The engine system is responsible to send the command to ballast compartment whether to increase or decrease the level of water in the ballast compartment. So the attacker will send a false command. Due to this false command, it may cause sinking of ship. For example, even though there is need for the intake of water into the ballast compartment, the attacker may send the command that to discharge the water. Then there will be imbalance of the ship and it will cause the sink of the ship. The attacker can send the phishing email to the ballast system, and when the crew member clicks any link from the phishing email, the attacker can compromise the industrial control system network, where the attacker can alter the sensor and actuator which are responsible for water intake and discharge, where it causes the imbalance of the ship once the attacker will send the wrong command through the sensor and actuator management. And also the attacker can inject the virus through some USB ports available to the ballast water system, and due to these virus, the attacker can change the pumps and valves management, which like even the attacker can stop the working of these pumps and valves. So once these pumps and valves stopped working, there will be no intake and discharge of the water. This is the attack scenario of the ballast water system. The next one is cyber incidents in cargo management systems. The first one is, in 2012, hackers who are working for a criminal syndicate compromised the cargo system, which is controlled by Australian Customs and Border Protection Service Agency. The cyber criminals wanted to know which shipping containers were suspected by the police or custom authorities. That means by this, the attacker can gain the information like if there is any high value cargo or it is low value cargo. And another incident in August 2011, the hackers penetrated the servers of Iranian shipping line, which damaged the data with rates and also loading, cargo numbers, even the delivery dates and places. And after this attack, nobody could specify the location of that certain containers. In 2017, Naval Dome ethical hackers performed the penetration test. As discussed before, the Naval Dome ethical hackers in their first trial, they were able to gain access to the ECDIS and then to the radar. And finally, they were able to control the machinery control system. And in this operation, their first target was the ballast system. I mean, they are able to change the commands, which sends like to increase or decrease the level of water in the ballast compartment. So these are the cyber incidents for the cargo management systems. Summarizing the presentation, Priyanka and myself have discussed possible cyber risks of navigation systems and cargo management systems, even the propulsion machinery systems and communication systems. Here, you can see the overall risks of the OT systems displayed. There are some risks like USB ports, LAN, even the software of the systems, receiver, for example, GPS receiver, and computer systems, very high frequency radio, even the network switches, and also the server message block service, VSAT terminal, like very small aperture terminal, which is used for satellite communication, and also the modems and NMEA network. And here you can see the attacks of the overall systems. The attacker can perform the malware attack, even the denial of service, spoofing, replay attack, and also the jamming, backdoor attack, eavesdropping attack, man-in-the-middle attack, and ransomware attack, even the phishing attack. Thank you for listening to my presentation. Now I will hand over the session to Mark.
Okay, thank you, Ruchita. We will now move on to the Q&A and feedback session. You can click on the Q&A button that you see at the bottom of your screen to ask questions, view questions from other participants, and also upvote their question. So by upvoting their question, the question gets a higher priority to be answered. And we see that many questions have already been asked, and thank you for that. Keep them coming in. And because it is likely that we will not be able to answer every question at this webinar, we will do so offline after the webinar. And so now I'll leave it to the audience and the panelists to interact in this session. Thank you.
Okay, thanks, Mark, and also thank Priyanka and Ruchita's presentation. Now we see there are a number of questions already being raised. We will try to answer as many as possible.
Yes, Prof.
And we see the one on the top is that what's the meaning about hacking VAST? Is it the provider's equipment or shipboard OT shipboard equipment? I can answer this question. Here we mean the hacking VAST. We mean that the attacker can hack into the satellite communication, no matter it is the shipboard equipment or is the offshore, any other back-end equipment. The attacker can have access to this satellite communication. If it is compromised, then those attacks can be launched. Thank you. The second one in the list, many of these scenarios are Many of the scenarios require attacker to onboard or ship operations will have menu override if captain detects abnormalities. And here, for those kind of the scenarios, we demonstrated not necessary for the attackers be on board. The attackers can also launch those attacks remotely. And as long as they have the access to those shipboard OT systems. And ship operations will have. Yes, it's possible that the manual override be taken by the captain if they detect such kind of the abnormalities. But in some cases, when you detect it, maybe it is too late, and some may even may not be able to be detected very effectively. Next question is, what safeguard do we have to make the NMEA tamper-proof? We know that NMEA is already a standardized protocol. Here, our study is not aiming for providing kind of the improved version, or maybe a secure version of the NMEA. We mainly aim for providing the suggestions how we'll be able to mitigate such kind of the risks in case the vulnerabilities of the EMA, this vulnerabilities can be exploited by the attackers. The next question. Next question. In order to hack vast remotely, you require a complex equipment to be able to do that. And when this VSTA is compromised, these systems should have their manual bypass to resume operation instead of being idle. Of course, it depends on the capability and the type of the attackers who want to launch such an attack. If one of the ships is already being considered be a valuable target, then as long as they can exploit the vulnerability, even need complex equipment or the resources and skills, they were determined to do it. And it depends, it's highly dependent on the intention and the capability of the attackers. Next question. What are some of the guidelines considered for the study? Now, for this webinar, we mainly focusing on the study of the existing cyber risks to the shipboard OT systems. And for our next step is to provide the guidelines against those cyber risks. So we plan to schedule a separate webinar to share our study on our guideline to be provided.
Jining, you may want to scroll all the way up. I think there are some unfolded questions at the top, especially by Raymond and Sachin. Thanks.
This one, I think, already answered this question.
Okay.
For Raymond's question, I already answered it. Maybe you can mark it to be answered. And yes, and another question is hacking VAST may be possible. So do you suggest not to use VAST and thereby ship damage due to cyber attack can be avoided? No, we definitely need the communications so that our ship, the crew members and ship can communicate with our backend. And the issues here is how we will be able to secure this satellite communication to mitigate such kind of the risks being compromised. From Sachi, we have prepared a cyber security menu. Do you provide any service that reviews our menu? Yes, it's possible. We will be happy to collaborate with industry to share our knowledge on cybersecurity, especially relevant to maritime. Can the virus introduced from IG question is, can the virus introduced by external USB will help also hijack for easy access to shipboard system? Yes, and the virus being introduced through this external USB will definitely introduce more risks of the shipboard system being compromised. And this is one of the major risks that the various kind of the attacks that can be injected into shipboard systems through USB, external USB, and we have not prepared the guidelines yet. But one suggestion is that we need to have a very strict management and control on the use of those external USBs. For example, for all those external USBs being brought on board, need to go through very strict security scanning before they are allowed to bring to the ship. Is the best way to train for cybersecurity from Jalinko? Yes, and in SUTD, we have one master program called MSSD, Master of Science in Security by Design. And we welcome anyone interested to enroll into this program. This is a 1-year program for full-time students and 2 years for part-time students. And it started from 2017, and now we have, every year we have about 40 students taking our program. And one of the main unique feature of this program is that cyber physical system security is quite unique, and we in iTrust we have a world-class cyber physical system test beds for water, power grid, and also for IoT. And the students can use those test beds when taking the courses under MSSD. So next question from Matthew. What is the time to impact for these scenarios where ships collide or sink? I would think it will take a few hours for the ballast water attack. Crew can respond in time. Yes, if you can and discover the attack in time, then you will have time. You may have time to respond to those attacks to stop the potential damages. But in some scenarios, the attacker can be stealthy, and it will be hard to detect those kind of attacks before the physical damage being caused. So it depends on the type of attacks and the capability of the crew members, how they have been trained to deal with the scenario. Okay, there are so many questions. I try to answer one or two before we end this webinar. I try to pick the latest one. How to control the virus to attack the navigation equipment such as ECDIS radars. It's a very important and critical equipment on board the vessel. Yes, and so far we have not prepared what is the most effective way to be suggested to defend those kind of attacks, and we will further study it and then give our suggestions in the next webinar. The last question I try to answer is from Ian. Is there any strict regulations emphasize that contractor service providers installing communication equipment on board ship must have to comply such cyber security standards and compliance? I think this is one of the issues we want to address by providing this guideline to the Maritime Authority and also the ship owners to manage those cyber risks against the shipboard OT systems. And so they can use this guideline to see how will they enforce it when they face various kind of the operation scenarios to try to minimize the potential attacks to shipboard OT systems. Okay, so due to time constraint, I will stop here to answer questions, but we will try to answer all those the questions not being responded offline, and here myself and the team members would like to thank everyone for attending our webinar, and also thank you for your valuable comments and feedback. And As I mentioned, that this is our first webinar to share our study of the existing cyber risks to shipboard OT systems. We will schedule the second webinar a few months later to share our draft guideline for comments, and also to help us for deeper investigation. And we seek ship owners' support to help us to schedule the visit to your vessels. So far, we have already had 2 visits. One is the barge vessel, another is the container vessel, and that helped us a lot to have a very good understanding of the shipboard OT systems. Once again, thank you for your support, and wish everyone a wonderful new year ahead. Thank you very much.
Okay, thanks, Jianing. So just a reminder, we will send out an email to everyone. We have your contacts. We will send out an email to everyone to let you know where you can download a copy of not just the video, the slides as well, and also, as what Prof mentioned, any questions that have remained unanswered, we will collate them and answer in a Word document formats. So do check out our email. If you don't receive, maybe it's in your spam inbox. So thank you, everyone, and have a early Merry Christmas and Happy New Year. Thank you.